What lies in the perpetual darkness of our planet's deepest oceans? For millennia, we have gazed upon the surface of the sea, wondering what secrets it holds. Its vast blue expanse covers more than two-thirds of our world, yet we know more about the surface of the moon than we do about the ocean floor. It is a realm of crushing pressure and absolute blackness, a place long thought to be a barren, lifeless desert. But here, in this seemingly inhospitable abyss, lies one of the greatest discoveries of modern science. It's a world so strange, so utterly alien, that it forces us to reconsider the very definition of life itself. Imagine a landscape of perpetual night. There is no dawn, there is no dusk, only an endless, unchanging blackness. This is the abyssal plain, the floor of the deep ocean. Sunlight cannot penetrate these profound depths. For every 10 meters we descend into the ocean, the pressure increases by 1 atmosphere. At the depths where we find these hydrothermal vents, the pressure can exceed 300 atmospheres. This is equivalent to having the weight of a large van pressing down on every square inch of your body. It is a force that would instantly crush any land-dwelling creature. The temperature is just a few degrees above freezing. It is silent, still and profoundly dark. The creatures that inhabit this world have no air-filled spaces like lungs or swim bladders that would collapse. Their bodies are made mostly of water, virtually incompressible, allowing them to withstand the immense squeeze. What are these extraordinary structures, these hydrothermal vents? They are, in essence, underwater hot springs. They form along the mid-ocean ridges where seawater percolates down through fissures and cracks, becomes heated by magma and dissolves minerals and metals from the surrounding rock. Hydrogen sulfide, iron, manganese, zinc. Being less dense than the cold seawater around it, this hot, mineral-rich fluid rises. The dissolved minerals instantly precipitate out, building chimney-like structures over time. Some chimneys, known as black smokers, spew dark plumes rich in iron and sulfur compounds. Others, white smokers, emit lighter minerals, barium, calcium, silicon. These chimneys can grow rapidly, sometimes 30 centimeters in a day, and rise over 60 meters, creating a jagged skyline on the ocean floor. But they're ephemeral. Vents can clog or die as plumbing shifts, while new vents spring up nearby. They are geological cities in constant construction and demolition. In this world of extremes, one might expect only the hardiest microbes. But what scientists discovered was a revelation. Clustered densely around the vents is a menagerie of bizarre and beautiful creatures, forming an ecosystem as rich and complex as a coral reef or a rainforest. But unlike those familiar ecosystems, this one is built on a completely different foundation. There are no plants, no algae, no photosynthesis. The primary producers are bacteria, chemoautotrophs, drawing energy from chemistry, not light. These bacteria oxidize hydrogen sulfide and convert carbon dioxide into organic matter, the base of the vent food web. Strange, pale crabs scrape bacterial mats. Swarms of ghostly shrimp graze, fish, anemones, limpets, each uniquely adapted and dependent on these microbes. It is a complete, self-contained food web, isolated from the sunlit world above, a biological revolution. The discovery of chemosynthesis changed biology forever. It showed life could exist independent of the sun. It revealed a second pathway for life, chemical energy from the earth powering ecosystems. If life thrives at the ocean bottom, where else might it be found? Among the most iconic inhabitants are the giant tube worms, Riftia pachyptila, truly otherworldly. They can grow over 2 meters, standing upright in dense thickets like an underwater garden. They have no mouth, no gut, no anus. Instead, they have a trophosome packed with billions of chemosynthetic bacteria. The worm provides a safe home. The bacteria produce sugars and organic compounds that nourish the host. The worm's bright red plume absorbs hydrogen sulfide, oxygen and carbon dioxide, transporting both safely to the bacteria within. The plume is red from hemoglobin, the same molecule as in our blood, but adapted to bind both oxygen and toxic hydrogen sulfide. Ghostly white vent crabs bear light-sensing organs on their backs, thought to detect faint thermal glow and guide them to food-rich areas. The scaly foot snail wears iron sulfide scales, the only known animal to incorporate iron into its armorous foot. These creatures are living testaments to evolution, producing novel solutions to extreme challenges, crafting life from the minerals that surround them. These vents are not just geological wonders, they are living laboratories of evolution in action. Let us delve deeper into this remarkable process, chemosynthesis. While photosynthesis uses light energy, chemosynthesis uses chemical energy. The bacteria take carbon dioxide, water, and a chemical energy source, hydrogen sulfide. They convert those into sugars. The sugars power the bacteria to live and reproduce, forming the base of the vent food web. This process is the engine driving this deep-sea metropolis, a biological miracle in absolute darkness. The discovery of chemosynthesis was revolutionary, a true paradigm shift. Some scientists believe chemosynthesis was among the earliest metabolisms. Early life may have arisen in vents like these. These ecosystems may be living windows into our distant past, a glimpse of life at its dawn. If life thrives here, where else might it be found? Deep within the Earth's crust? In subterranean aquifers? Other dark corners of our planet? The creatures of the vent world are masters of adaptation. Every aspect of their biology has been finely tuned by evolution. Consider the Pompeii worm, one of the most heat-tolerant complex animals, living attached to black smoker chimneys where gradients are extreme. It can withstand water temperatures over 80 degrees Celsius. The worm's back is covered in a fleece of filamentous bacteria that may insulate and detoxify and may provide nutrition. The worm secretes mucus that feeds its symbionts, a complex mutualism. At the molecular level, vent animals evolved piezolites and stabilizing proteins to keep enzymes and membranes functioning under pressure. From armored snails to heat-proof worms and glow-detecting crabs, every creature is a marvel of evolutionary engineering. These vents are living laboratories, showing us life's creative force at work. The discovery of hydrothermal vent ecosystems forced a wholesale re-evaluation of the necessary conditions for life. For decades, the search for life sought planets in the Goldilocks zone, liquid water and light. The vents provided a new blueprint, life powered by geothermal chemistry. Could life exist on Jupiter's moon Europa, a subsurface ocean heated by tidal flexing? If vents exist there, might they support ecosystems hidden beneath ice? Cassini flew through plumes from Enceladus and found water vapor, ice grains, salt and simple organics, tantalizing clues. These icy moons are prime candidates. Geology, internal heat may expand the range of potentially habitable worlds. The secrets of our deep ocean offer new clues. Perhaps life does not need a sun, only chemistry and liquid water. The universe might be far more hospitable to life than we imagined. Our journey into the deep has brought us face to face with a world that challenges our every assumption. Crushing pressure, toxic chemistry, blistering heat. Yet it is bursting with life. We've explored less than 5% of our planet's oceans. Every expedition brings new species, new behaviors, new questions. We are not just cataloguing creatures. We are piecing together the story of life on Earth and the principles that might govern life everywhere. The secrets of deep-sea vents have revealed not only what lurks beneath, but have illuminated the boundless possibilities for life across the universe. So as we look up at the night sky, at countless stars and planets, the question, "Are we alone?" takes on a new dimension. Perhaps we have been looking in the wrong places. The answer may not be found by looking up, but by looking down, into the fiery heart of the abyss. What else lurks in the depths yet to be discovered?